Right, good day, grade 11 mathematics learners, and welcome to this session. Today, we will be having a look at your June examination preparation for 2023 for mathematics, and we will specifically be having a look at paper one. Right, so the topics for paper one that you should be studying is algebra, that will be plus or minus 45 marks, functions and graphs plus or minus 40 marks, and number patterns, which is plus or minus 15 marks. Remember, it will count a total out of 100 marks, and your time is you will have 2 hours to complete your examination. Some hints and general guidelines will be: remember your writing materials. Yes, please be prepared regarding all your writing materials, your stationery, your calculator, etc. when you are going into your online examination. Please read the instructions very carefully. It's specific for mathematics as well. It will state in the instructions how you need to answer the questions, how you should round off, etc. And then you have 100 marks for 120 minutes. That's 2 hours. That's 1,2 minutes per mark. Do not spend too much time on difficult questions. Rather, answer questions that you can do. And the golden rule is usually that we follow is 1 minute for 1 mark. Do not spend 15 minutes on a 3-mark question. You will run out of time for the rest of the paper. Please write clearly, neatly, and legibly. And then round off answers correct to 2 decimal places unless otherwise stated in the question. And then please remember to show all working and your answer. Do not just provide an answer. We also need to see the steps that you have completed. Right, the level of questions you can expect in your test or your examination. We have a level 1, level 2, level 3, level 4. Level 1 is usually called knowledge. It counts 20% of your examination. Knowledge forms the foundation of the content that is being learned. It is the content that students must know of by heart. Right? These are usually your facts, the reading of certain things on a graph, identifying a variable, etc. And then level 2, this is routine procedures. This consists of the questions that you do in the class each day and in your textbook as well. Routine procedures are standard methods and application of theory. It is typically examples shown in class or in your textbook that you should be familiar with. And then you get your level 3, that is complex procedures, that counts 30%. Complex procedures may also be standard method, but then it involves application from various topics or multiple steps to find a solution. And then you get your level 4, consists 15% of your examination paper, whereas complex procedures consist 30%. This is the problem solving level. So it's usually an unseen question. Problem solving is not expressly taught in content, but rather its overall aim of the subject to solve problems and to use the content of the lower levels to do so. Right, we're going to start with our algebra. This is a typical layout or format that you will see for your paper 1 examination as well. Now for question 1 for 1.1, it states here we need to solve for x. That's the instruction. Please note that the mark allocation for each question is usually higher than the previous one. Okay, so there's an increase in difficulty as you've seen on the levels that we've just covered. So for 1.1.1, 2x minus 3 times x plus 7 equals 0. It's already in a form that you can just solve it. Remember, you need to make each bracket equal to 0. So you'll have 2x minus 3 equals 0. So x will equal 3 over 2. Or x plus 7 equals 0. X equals negative 7. 1 mark for each. 1.1.2, 7x squared plus 3x minus 2 equals 0. It states here, leave your answer correct to 2 decimal places. The moment they say that, you have 2 choices. Either you have to complete the square, or you have to use the quadratic formula. Why not just use the quadratic formula? Because it's much easier for us than completing the square, and you can find the 2 answers correctly. Okay. So please remember, you do not have a formula sheet for grade 11 mathematics, you must know what the quadratic formula is. It's already in standard form, so you can just substitute in your a, b, and your c. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a, where your b is your 3, your a is your 7, and your c is your negative 2. So it equals minus, and then the 3 plus or minus square root of b squared, that's 3 squared minus 4 times 8 times c, so it's 4 times 7 times negative 2, all over 2a, where a is the 7, so it's 2 times 7. Then if you simplify that underneath the square root, you'll get negative 3 plus or minus square root of 65 over 14. On your calculator, the 1 will be negative 3 plus square root of 65 over 14. The other one will be negative 3 minus the square root of 65 over 14. You must round off to 2 decimal places. So you will have x equals negative 0.79 or x equals 0.36. You get a mark for the substitution for these values for a, b, and c into your quadratic formula. And then you get a mark for each of your values of x. And then 1.1.3. This is a third equation you have to solve for, 6 marks. Square root of x minus 1 plus 3 is equal to x. Remember, I'm going to move this 3 to the other side first. So it's the square root of x minus 1 equals x minus 3. And then to get rid of the square root, you need to square both sides. So x minus 1 bracket squared equals x minus 3 squared. Now, if you square something that has a square root, it just gets rid of it. It's the inverse operation. Only the x minus 1 is left. And then equals, if you FOIL that, you expand that x minus 3 squared, you will get x squared minus 6x plus 9. Now you need to rewrite this in standard form. So if you write that in standard form, you're going to move the x minus 1 to the right-hand side. You'll get x squared minus 7x plus 10 equals 0. You can factorize that into 2 brackets. X minus 2 times x minus 5 equals 0. So x equals 2 or x equals 5. But since there is a square root in our equation, you have to test both of them. You will see on your calculator that the 2 does not work. The left-hand side does not equal the right-hand side. Only the 5 works, so the 2 is not applicable. So you get a mark there for isolating, for taking the 3 to the other side. Then you get a mark for squaring both sides. Then you get a mark for standard form here. You get a mark for both factors, and you get a mark for x equals 5 and x is not equal to 2. Right, then we look at 1.4. For 1.1.4, this is a quadratic inequality. It works a little bit different. X squared is greater than 3 bracket x plus 6, 4 marks. So the first thing we do is you multiply that 3 in, then you'll get an x squared is greater than 3x plus 18. Then you need to move that 3x plus 18 to the other side to get it into standard form. So it will become x squared minus 3x minus 18 is greater than 0. Please remember that the direction of the inequality sign stays the same because I merely added or subtracted numbers or letters. I didn't multiply or divide by a negative. Only if you multiply divide by a negative, then the direction of the inequality sign will change. And then this you can factorize into 2 brackets. X minus 6 times x plus 3 is still greater than 0. So the two critical values are x equals 6 and x equals negative 3. So there's my negative 3, there's my positive 6. Now this is a parabola. And we know it will be a smiley face because it's a positive x squared in the front. So on your number line, on the x-axis here, there you have drawn your parabola. There are your two critical values. And now you need to go back to the question here, x squared minus 3x minus 18 is greater than 0. So we're asking, where's our parabola strictly above the x-axis? Now only this part here, not including the negative 3, not including the 6, but this entire part here, there you will be above the x-axis. Also here. So it's everything to the left of the negative 3, you will be above it. So x is less than negative 3, or everything to the right of the 6, you will be above this x-axis. So x is greater than 6. You get a mark for the standard form. You get a mark for the factors. You get a mark for x is less than -3, and you get a mark for x is greater than 6. And then 1.2, solve for x and y simultaneously. This is simultaneous equations. 2y plus x equals 1. That's a linear equation. That's equation number 1. And x squared plus y squared plus 3xy plus y equals 0. This is equation number 2. This is a quadratic. So because you have an x squared and a y squared, you will have 2 values for x and you will have 2 values for y. Right, and if you look at equation number 1, you can get x by itself. You just move the 2y to the other side. So x equals 1 minus 2y. This is equation number 3. And you get a mark for that. Now you must take this x equals 1 minus 2y and you must substitute it in the place of x in the second equation. So meaning there and there. So then you'll have 1 minus 2y being squared plus y squared plus 3y times your 1 minus 2y and then plus y equals 0. All of this you need to then expand and then you need to simplify. So if you expand all of that, you'll have 1 minus 4y plus 4y squared plus y squared plus 3y minus 6y squared plus y equals 0. Then you will have, if you collect like terms there, only the 1 minus the y squared equals 0 will be left. That's standard form. That's a difference of squares. You can factorize that into two brackets. 1 minus y times 1 plus y equals 0. So y equals 1 or y equals -1. And then you must take both of them. You can substitute them back into this third equation, x equals 1 minus 2y, and find the values of x. So x equals 1 minus 2 times 1. That will give you x equals -1, or x equals 1 minus 2 times -1. Then you'll get x equals 3. So you get a mark for that third equation by getting x by itself. You get a mark for substituting that into the second equation. You get a mark for the standard form, which is this one here. You get a mark for the factors. You get a mark for both y values. And you get a mark for both x values. And then 1.3, if f of x equals 0, so they are solving here for a quadratic function. Has the roots x equals -5 plus or minus the square root of 3 minus 12k squared all over 4. So this is the quadratic formula. Okay, so there was a quadratic function. It wasn't standard form. They set it equal to 0, so they're trying to solve for x. And so they're using the quadratic formula. And then it says, comma, for which values of k will the roots be equal? Now, they're referring to the nature of roots here, and specifically the discriminant. Now, where can you find this discriminant? It's underneath the square root here. Remember, it was b squared minus 4ac. Well, they've already worked it out and it equated to this, 3 minus 12k squared. Now, where it has equal roots, that's where the discriminant equals 0. So we must set 3 minus 12k squared equals to 0. Now you must just solve for k. So you can take out a 3 there, then you'll have 1 minus 4k squared equals 0. K squared equals 1 over 4. And so k will equals plus or minus a half. So you get a mark there for k equals plus or minus a half. You get a mark there for k squared equals a quarter. And you get a mark there for equating your discriminant equal to 0. Right, and then question 2.1. Simplify fully without using a calculator. 4 marks. Okay. So 3 to the exponent of m plus 4 minus 6 times 3 to the exponent of m plus 1 all over 7 times 3 to the exponent of m plus 2. So what you can do here, you can take out a 3 to the exponent of m plus 1 out of both of these two terms here in the numerator's position. Then you'll have a bracket, only the 3 to the exponent 3 will be left, and then minus the 6. All over, now you can do split here in the denominator's position. It's 7 times m to the exponent of 3 to the exponent of m plus 1 times 3 to the exponent of a 1. Remember, we are splitting this because if the bases are the same, there's a multiplication, you can add the exponents, there's a 1 here. So it will still give you that 3 to the exponent of m plus 2. Now something interesting will happen. This 3 to the exponent of m plus 1 will cancel with this 3 to the exponent of m plus 1. Only this 3 cubed minus 6 over 6 times 3 will be left. So that is what's left here. That you can work out in your calculator. The top will give you a 21. And the bottom, the 7 times 3 will also give you 21. 21 divided by 21 is just 1. So you get a mark there for the common factor that you have taken out, the 3 to the exponent m plus 1. You'll get a mark there for 3 to the exponent 3 minus 6, which is this one here in the bracket. You'll get a mark here for your simplification, and you'll get a mark here for your answer. Right, this is just one method of solving, or sorry, simplifying this expression. And then 2.2, solve for x without using a calculator. 2.2.1, this is rational exponents. X to the exponent negative 3 over 4 is equal to 8, 3 marks. Right. Now the first thing that you can do is you can rewrite that 8 as a base of 2 with an exponent of 3, right? 2 times 2 times 2. So 2 to the exponent 3, close the bracket, and here what we did here was we raised it to the reciprocal of this negative 3 over 4, because you want the x to the 1. So if you want the x to the 1, you need to raise the left-hand side to the negative 4 over 3. And you also need to raise this to a negative 4 over 3, or 4 over negative 3 is the same. And then the 3 and the 3 will cancel, only the 4 and the negative will be left. So x equals 2 to the negative 4, so x equals 1 over 16. And you can test it, substitute it back in here for x, and you will get 8 as an answer. So you get a mark there for change to a prime base of 2. You get a mark there for the rational exponent that you raised it to the 4 over negative 3, or negative 4 over 3. And then you get a mark there for your answer, x equals 1 over 16. And then 2.2.2, 4 to the exponent x minus 2 to the exponent x equals 2, 4 marks. The first thing that you do is you move this 2 to the left side. So 2 to the exponent 2x minus 2 to the exponent of x minus 2 equals 0. That you can factorize into two brackets. 2 to the exponent x plus 1 times 2 to the exponent x minus 2 equals 0. Remember this 4 to the exponent of x. You can rewrite that as 2 to the exponent of 2 to the exponent of x. Okay, then it becomes 2 to the exponent of 2x. Right, and you set each bracket equal to 0. 2 to the exponent of x plus 1 equals 0. 2 to the exponent of x equals negative 1. There's no solution for that. And the other one's 2 to the exponent x equals 2 to the 1. Therefore, x is only equal to 1. It's the only solution that works. You get a mark there for standard form. You get a mark there for your factors. You get a mark there for x equals 1. And you get a mark there for saying 2 to the exponent x does not equal to 1, or there's no solution for x there. Right? If we look at 2.3, x equals 3 minus square root of a over square root of 2. And y equals 4 plus square root of a over square root of 2. Determine the value of x plus y squared. That's 3 marks. So you can just substitute them in here. Here's the x plus here's the y. Remember, denominators are the same, so we can add the numerators. 3 plus the 4 is a 7. Negative a squared plus a squared is 0. So only the 7 is left over our LCD, our common denominator there of 2. And you still need to square that. So if you square 7 over square root of 2 squared, you'll get 49 over 2. That's 24.5. So you get a mark there for substituting in the x and the y that they've given to you. You get a mark here for the simplification, and you get a mark there for your answer. Now you can leave it as 49 over 2, or as a mixed fraction, 24.5. And then 2.4, show without using a calculator that the 12th root of 10 times the 6th root of 640 times the 4th root of 810 times the square root of 40 equals 124 marks. Okay. So what we definitely can do here is this 12th root of 10. We can rewrite that as 10 to the exponent 1 over 12 and then times the rest. Remember, the 6th root of 640, that 640, you can break it up into a 64 times 10 times the 4th root of 810. You can break it up into the 4th root of 81 times 10. And the 40, you can break it up into square root of 40 times 10. Remember, we're only working on the left-hand side because we want to show that the left-hand side equals the right-hand side. So we're not touching this 120, we're working here on the left-hand side. And then it's 10 to the exponent of 1 over 12 times the 6th root of, that's 64. You can rewrite it as 2 to the exponent 6 times 10. Times the 4th root of that, 81. You can write it as 3 to the exponent of 4 times 10. Times, remember, square root of 4 times 10 will be 2 square root 2 times 10. And now you can rewrite all of this in exponential form. So it's 10 to the exponent of 1 over 12 times 2 to the exponent of 6 over 6. Remember, we're taking the 6th root here. Times 10 to the exponent of 1 over 6 times 3 to the exponent of 4 over 4 times 10 to the exponent of 1 over 4 because we're taking the 4th root for both of these. And then times 2 to the exponent of 2 over 2. Remember, there's actually a 2 here. And then times 10 to the exponent of 1 over 2.5. Now, if you work that out, we will have 2 to the exponent of 6 over 2. That's 2 to the exponent of 1. That's 2. And then we have 3 to the exponent of 4 over 4. That's 3 to the exponent of 1. That's 3. And we have a 2 to the exponent of 2 over 2. That's 2 to the exponent of 1. That's 2. And then you can work with the base of 10. It's 10 to the exponent of 1 over 2 times 10 to the exponent of 1 over 6 times 10 to the exponent 1 over 2. Remember, the bases are the same. There's a multiplication, so you can add their fractions that are exponents. Then you'll get, it's 10 to the exponent of 12 over 12, and that's 1. So it'll be 2 times 3 times 2 times 10 to the 1, and that will give you 120. Good. Thank you very much for your time. In the next session, we'll be having a look at number patterns and then functions. Goodbye.